Today we're going to take a look at SQL versus NoSQL databases. Specifically, we're going to compare relational databases to MongoDB. What is SQL? SQL stands for Structured Query Language. Technically, SQL is not a database, but a programming language to interact with structured databases. SQL commands work on data in tables. Commands include words such as insert, update, select, and delete. Here's an example of a SQL command. The most common command begins with the word select, select asterisk from products. Notice how select and from are in all caps. Those are SQL keywords. That is the programming convention for the SQL programming language. In this example, the asterisk means select all of the fields from the products table. You can also be more explicit in which fields you select. You can list them. Select, for example, product ID, product name, price from products. These field names and the table are data or parameters. As I said before, SQL databases are structured in tables. Table has a unique identifier known as the index, in this case, product ID. Multiple tables can be linked together using indexes. In the previous example, each record in the product table is linked to one item that has a product name and price. Another table called orders, for example, might contain many products that someone purchased. Since they could order many products, since each individual customer could order many products, this would be a one-to-many relationship. Okay, the diagram below this is interesting. It shows linked tables and their relationships, and the lines between the boxes show the type of relationship between the tables. And the single mark next to the table means that it's one, and the double mark next to the table means that it is multiple or many. Now we'll talk about types of relationships in SQL-enabled databases or relational databases. There's one-to-one, that's very common. One-to-many, that's perhaps even more common. And many-to-many. There's also something called self-referencing, where a table refers to itself. Okay, how is a relational database structured? Well, structured in what are known as schemas. The structure and relationships among tables is called a schema. Relational databases have strict rules about the types of data in fields. Once you declare that type of data, it tends to remain that type of data. It's fairly difficult to change. SQL rules. If you add a field to a table, every record in that table also has to have that field. This is true even if the field is empty for that particular record. Relational databases can get around this issue by linking tables and using a one-to-many relationship or a many-to-many relationship. Linking tables can allow either one or many members of the same field as long as each new field instance has a new index. SQL databases can be scaled. Some people say they can't. They can up to a point, and then it gets difficult. It's a special kind of scaling called vertical scaling. The issue is that relational databases are meant for a single server. So to scale it, to have more memory or more concurrent users, you need to upgrade the server. This is called vertical scaling. You either have more RAM or more CPU or processing power, or most likely all of the above if you're going to upgrade. NoSQL databases are significantly different. NoSQL means not only SQL. They're also called non-relational databases. They are extremely flexible. And they're often used for big data and some real-time web applications. Facebook and Google are said to use them. There are several types of NoSQL databases, but primarily I'm going to talk about MongoDB in particular. MongoDB is a document database. There are other types, such as key value stores and column databases. MongoDB is said to be good at working with big data. What is big data? That's when the data volume and the number of queries occurring at the same time make conventional relational databases start breaking down. It also refers to when high enough volume where traditional storage and processing methods are no longer adequate. I've heard of big data described as above 100 gigabytes of data. That's a lot, and not a whole lot of programmers get to that point or use that much data. But the Google and Facebook certainly do use more than that, I'm sure. A more frequent issue than just having big data is when the number of complex queries going on at the same time is too high for traditional databases. NoSQL, like I said before, is good for some types of big data. Oops. Okay. There are also other use cases for NoSQL other than big data. That is because it is very flexible. Well, I'm talking about MongoDB in particular, but NoSQL as well. you can add fields that only some records will need to have. I can add as many phone numbers as I want, or as many email addresses as I want, or what have you. And it won't mess up the table, and you don't have to add columns to the table that end up having empty values for everyone else that doesn't have that many email addresses or phone numbers. Found out in MongoDB, for example, documents in a single collection do not need to have the same set of fields. Also, a field's data type can differ across a collection's documents, according to the MongoDB manual. NoSQL, or MongoDB specifically, they are very, very flexible. MongoDB lets users change a collection's document structure, including adding new fields or removing existing fields. It's not so easy to do in relational databases. MongoDB also lets users change the field values to a new type or update the documents to a new structure. MongoDB data is in the form of collections and documents. Collections of documents, I should say. Documents can be somewhat analogous to tables. Sometimes a single operation can refer to multiple documents. However, referring to multiple documents incurs cost and performance. Therefore, it's recommended to make a schema with a single document that has embedded documents within it. That improves performance. MongoDB is said to be atomic on the level of a single document, meaning that it's self-contained. For example, a write operation is said to be atomic on the single document level, even if it modifies multiple embedded documents. For example, the document below has embedded documents of content and access. NoSQL databases can be very easily scaled. It's not just vertical scaling, but horizontal scaling. What does that mean? That means instead of being on one server, NoSQL databases can be spread across multiple servers. NoSQL databases such as MongoDB can be partitioned across multiple servers. And this process of partitioning data across multiple servers is called sharding. So instead of buying a more powerful server, you get more servers. Here are my references. You can find out more about it from the MongoDB manual. And if you have any other questions, Quora is probably someone has already asked them in Quora. Thanks.